The NC Lab 2020 webinar series is funded through a grant from the Institute for Museum and Library Services and provided to the Nevada State Library Archives and Public Records System. The topic of webinar 3 is Introduction to Computer Programming, or Karel, Unit 2. So I am now going to go to Unit 2 here. All right, so this is a similar document to Unit 1. And this gets into, I think, what's the fun part of programming, because you learn pretty quickly that you can't control things. One of the beauties of programming is it'll go into a situation where you don't know what's going on, and it will figure it out as you go. So in Unit 2, that's really what you're learning how to do. Conditions show up that you don't know in advance, and the program learns how to react to those conditions and carry out a set of actions.
Sounds
And
kind of resonant.
yes, it does, doesn't it? Oh my goodness. I think I keep seeing this whole coronavirus thing as a massive stress test on everything. It's like, oh, I never in a million years would I have ever thought that someone would be asking people to pay them $30 a barrel to get rid of their oil. But there we go. Fortunately, it seems like it was a short episode, although what I was reading this morning is that they expect a lot of volatility for a while yet. But still, it's, yes. Well, and it brings us back to that first point about when you're writing a program, you're going to make several iterations to make sure you've got everything working. So this is a massive iteration right now. We're finding out all the stuff that doesn't work, and hopefully we'll be better for it at the end of the day if we can get some consensus on what to do. Anyway, so there's one of the parts of understanding a condition is that you have to be able to sense it. So we're also learning, we're not only learning how to respond to conditions, we're learning how to sense them. And then this is a big mouthful here, this word Boolean operations. I remember seeing those in math books and it sounded very fancy. What it boils down to a lot of times is whether you're going to look at two things at the same time, multiple things at the same time, and they both have to be happening, or one of them has to be happening, which is when you use or they're not happening. Actually, it took a 19th century mathematician to understand the importance of that, or find a way to write it down mathematically. And then computing science really ran with this idea. So again, there's just a quick view of the sections, because here we only have 5 sections, but they start at number 6 and end at number 10, and it's in Unit 2. That can also be confusing, so I wrote that out. I didn't repeat the part on how you earn points because you can get that from the first document. And here we are in section 6. So the first type of condition testing we're going to learn about is the if statement. And Karel is going to sense something depending on what it is, either right on the square where Karel is or the square in front. So if it's an obstacle, in other words, if Karel moves and an obstacle is there, Karel's going to crash. So that's a sensor in front. And then when you're picking up or putting something, it's a sensor underneath. It's in the same square as Karel. So this is a very simple bit of code. It's using that repeat structure because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. But what Karel is doing before moving forward is sensing whether there's an OR-kit on that square or not. And if there's an OR-kit, Karel's going to pick it up with the get command. And it doesn't matter if your maze looks like this, a few scattered OR-kits, or if there's no OR-kits, or if every single square has an OR-kit, this program will work. And I know, when I first started learning programming, stuff like this just blew my mind. It's like, it's so simple, but look at how powerful it is. So to me, this is exciting, but then those are the sort of things that get me excited. So then, you have this, again, this nested structure, just like a repeat loop. So you're indenting, and then anything that's indented, like this get command, is what Karel's going to do if the condition is true. And I put true in capital letters, or capitalized, I should say, because the Boolean true is capitalized. It's actually a command or it's written that way in Python with a capital letter. And then you know in Python that you're looking for a Boolean true. There's Boolean true and Boolean false. There's only two values in Boolean values, true and false. So we're kind of getting that using the language correctly right from the get-go. So once you practice that a bit, then we're going to look at, okay, so if it's true, I'm going to do this. But if it's not true, I want to do a different set of actions. So that's called an else branch. And it goes from there. In Python, you've got intermediate branches that are called elif branches. And at the end, you have an else. You can get some pretty complex logical structures using if, elif, and else. Here we're just worried about if and else. So if the condition is false, then it's going to execute what's called the else branch. We're also learning some new sensors. So we're going to monitor what Karel's collected, and I'll show you what that looks like in a moment. And then we're also using a directional sensor called north. So Karel could be facing all kinds of directions. Excuse me, if Karel's facing east and we just tell him to go, he might crash into that boundary. It may be that we want to point him in a certain direction first before executing the next set of commands. So north simply means that Karel is facing north, and then you can precisely turn Karel where you want it and start the next set of actions. There's also the pass command, and that simply means if a condition is true or false, depending on what it is, Karel just doesn't do anything. So sometimes that's a useful command. All that's taught in section 7. And then in section 8, now you're combining conditions. So in this little maze here, you can see there's a nugget, there's a gem, there's a bottle, there's some gears. So now what we're telling Karel to do is Karel's going to pick up an object if it's a nugget or a gem. If it's the bottle or the gears, Karel's just going to ignore that. So now I'm getting some pretty selective behavior. And as Karel goes through, it'll use this test and then continue with this repeat pattern. So this is getting pretty sophisticated. Still only 7 lines of code. There's a lot going on in it. Then in section 9, we get into something called a while loop. And I know when I first started learning if statements and while loops, I got them confused. But a while loop is basically a conditional repeat loop. A repeat loop, you know exactly how many times you're going to repeat a pattern. A while loop, you don't know how many times in advance you're going to repeat it. So here's the program. Karel goes one step forward, and as long as there's a barrel, Karel's going to get it and keep going. Once there are no more barrels, the program will end. Karel will stop. And so this little bit of code here is going to work whether there's 6 barrels or 10 barrels or 4 barrels or no barrels. It's quite a powerful structure. And then 10, you're just practicing everything together, combinations of while and if conditions. And this is where the first complex algorithm is taught, and it's called the first wall algorithm because Karel is learning what to do when presented with a wall and how to turn. So this is getting into a little more sophisticated programming. And again, just like in Unit 1, you get a certificate, And these are quite professional looking, so it's a good portfolio piece to have that certificate in hand. So what does this look like? Let's go to Unit 2. And we'll just do the demo levels here. This is demo level. And again, the instructions, there's story, there's video, there's a detailed tutorial. One thing that Dr. Solon has added are these try it yourselves. So you don't have to wait until you get to that main screen where you're really trying to work through it all together. You can click open a little program and run it. So in this case, Dr. Solon's just showing you what happens if you hit a wall. Okay, so I'm going to step through. Okay, so was there a wall? Nope. Oh, you know what? I just realized something. Okay. That's so in this case, Karel didn't encounter a wall, so so none of this was carried out. Okay, I see what he's doing. Okay, this is my first time through as well. So in this case, we're opening a second example. All right, and you can see Karel is facing a wall. Now this time when we run it, Karel's going to turn left and then left again to avoid crashing into the wall, and then keep going. So he's taking little chunks of the program and demonstrating them. Okay, and then there's some more stuff and explaining how the sensors work, and then a first demo level, and when you walk through it, you see exactly how Karel behaves. This stepping procedure is kind of important. A lot of times people just want to hit run and go through the program and just watch it fail. If you use step, you can see exactly how Karel reacts to a command, and also on the bottom it has the algorithm. I will pick up an object from the ground. So the algorithm is written out. I will make one step forward. And then I've now started cycle 9 of 10. That's your repeat cycle. I've checked the condition, and the condition's not satisfied. There's no ORCID there. So I'm going to go ahead and make one step forward. I'm skipping that if loop, the if statement, I should say. And there's my last cycle. This is my repeat 10. This is cycle 10 of 10 down here. And if there's an ORCID, yes, I'm going to pick it up. I'm going to go forward, and I've finished all my cycles, and I'm done. So at the beginning, they're using those fixed repeat loops. By the time you get to section 9, then we don't know how many times we're going to repeat it. So there's your try it yourselves, some more examples, the story, and then we can step through here, and Karel's made a step, condition satisfied. And so as long as that barrel is there, that repeat structure will keep repeating. And it doesn't matter how many are there to begin with. You'll see up here, there's 4 different mazes now, and these will randomly load to test someone's program. So this is how we can train ourselves on not knowing the condition in advance. Ta-da! Success. Okay. So, questions? Anything you want to discuss? Anything you need from me apart from the fact that I got to get these up online and send them to everybody?
Hi, Sheila. Yes, I definitely have some questions, and I
Okay.
hope my connection is okay. It's been
Your
been
connection's
a
great.
okay. It's been a
Yeah.
rocky day. Heard a recent news article about a demand for COBOL programming, that a lot of
Uh-huh.
unemployment is tied to programming from the '60s. That is COBOL. So it just use the word iterates the demand for this type of
Yes.
thinking and skills. But is there anything else you've heard lately that is directly tied to the crisis? Like there is a need for Python programmers because people are, experiencing slow internet or anything like that. Have you heard anything else like that?
Well, I just want to, I'll comment on your COBOL comment to begin with. When I was at a conference a couple years ago, we were next to an IBM booth. And one of the reasons COBOL is used is it's very stable. It's got, what is this, 2020? So it's got, when did it come in? The 60s. 50 plus years of debugging. It's very stable, and so it's really good for financial transactions. A lot of banks use it, and a lot of banks still like to have most of their um, inner workings self-contained, and they'll leak out little bits to the net as needed, but they want to have a very stable base. So yes, definitely those old programs. I think probably a big area, and this would involve Python, a big area that people are crunching right now is data. So you're building databases and pulling information out of the data. Python's really good at working with data. Um, there's a lot of tools in Python. There are a lot of libraries, Pandas and Seaborn and so forth, that you can use to parse data and run statistics on it and make predictions. So, and we do have college level courses that teach all that, but definitely one of the um, courses you guys have under the library contract are the Python programming fundamentals. And once someone has learned that, they can even go to python.org and try out some of those libraries. The libraries are very well documented. They have lots of examples. They show exactly how to use each technique. So yes, I would say Python's used quite a bit these days to make sense of incoming information. Um, and it's what's called a utility language. So like for instance, Python uh, talks a lot between the front end, which is what users see, and the back end, which is what's happening behind the scenes. Not quite the same thing as high level and low level. That's more machine versus human. But systems also have outward facing um, parts and inner workings, and Python's used a lot to connect the dots on that. So yeah, oh yeah, Python's alive and well. And I was interested when I started researching how Python came into use. uh, it got a huge boost from Google. So in the mid 90s, when Sergey Brin and Larry and those guys were messing around at Stanford doing their thesis, um, they were using C plus, I think. I can't remember which version of C. And then there's this language called Python. So they tried it in their search algorithm, and it worked way better. And so Python and Google are intimately tied from the beginning. And, I was running a business at the time and using search engines. And all of a sudden there was this Google search engine. And it blew me away, first of all, how fast it was. And secondly, how quickly it got to what I was looking for. So, it was my secret weapon until everybody else learned about it. But yes, so Python's used a lot with data. Um, Long story short, it's still very viable. Any other questions or comments?
Yeah, I have another one if no one
Sure.
else
Thanks,
does.
John.
I see Jessica and Robin here from Washington County Library System, and our charge is turning a lot of our in-house programs to virtual over the near term. So curious if Jessica and Robin or Charlene and Alejandra have plans or ideas for taking what they were doing in the branch to virtual.
Yeah, this is Charlene. I know that for our summer reading program, we are not doing all the programs that we usually do. I don't know if we're doing any at all or if they're all getting scrapped as far as in the library proper programs, but there is a big push for us in Boulder City to get as many what we would normally do with programs in person to get them online. There's a huge push to do that. And I was just thinking about, based on kind of what you were saying last time about a club maybe online just for people to share, like a Zoom meeting once a week or something, just to kind of share what they're doing, because it's such an independent thing, programming, especially this course. It's great that it's independent, but also there is that social aspect of sharing. So I think that that's kind of what I'm working on, since I'm kind of in charge of our coding clubs. So I'm trying to think of what I can do to make that more interesting.
Yeah. Yeah, and that's where you might, all those projects, that's something, once they've learned a skill, you really want to try and see what you can do with it on your own. And, we have project suggestions, but they can come up with their own too. And even with Karel's a robot, so you can simulate certain actions, even in the game mode. And, last year, I'm going to share my screen again just briefly. So I can go to community. Just going to open that up. Okay, and just an example here, theme projects. Okay, so the theme project I did, the sample was a Karel game that met the Earth Day theme. Let that load for a second here. Okay. So this is just showing how to use the blah, blah, blah. You can tell I'm a teacher. I talk too much. Tons and tons of stuff. Okay, where are we? It's planning it out. Okay. It was just showing how they can use the app to make a game. In this case, Karel was saving some bees that had been, the bee colonies had been destroyed by overuse of chemicals. And, Karel cleans up the barrels and avoids the dead hives. So it's simple, but sometimes when you give people simple constraints, they're forced to think a little harder. And that's life. And, a lot of times, oh man, if you had $1 million and all the time in the world, you could solve a problem, but you don't. You have minus $10 and you have very few tools. So, sometimes working with constraints like that is good. It's okay. All right, I'm going to simulate something using Karel, and Karel only has limited choices as to what I can use, but that's training your thinking. So it could be that that might be a possibility that they can create a game in Karel that solves a problem. And the game maker in Karel, let's go back here. I'm going to close that and close the course. Okay, Creative Suite, Karel. Okay, you have lots of opportunities to, just like how Pavel creates the courses, you can have lots of tutorials pages that have text. They can put in pictures. They can even add a little video to them. and these are all shareable. So they can, once they've converted it to a game, they can share the URL of their game with other people. So, you know, that's something you can certainly do online as well as live.
Are there, I know you just showed the one that for Earth Day that you did. Are there a lot of different challenges like that? I really like that idea of giving them something to work on and then come back in the next week and show and share what you did.
Right. So under instructor resources, and yeah, if for some reason you can't get in, just let me know. You should all have access to this. But here you can see a list of projects, and some of these are super simple. Okay, this is basically art. You can draw your name, right? But what does that do at the beginning? It's just manipulating obstacles and walls on a maze. So you're creating a maze and doing something with it. Something really simple and fun with a theme, and that can be shared. And those can be printed out as graphics too. You can take a screenshot, now you've got a graphic. So, you know, there's lots of project ideas in the instructor resources. Go back to that.
That's really great. I now see my club as a coding club challenge.
Mm-hmm. Yeah.
That's awesome. Thank you.
All right, and these more or less follow the progression of the course. You know, they get more difficult as you go up. But these projects were designed by a fellow that has worked a lot with kids. I really like the way he was thinking. So anyway, there you go. So a couple of ideas you can run with. And always, you know, if you have any questions, just email me at sheila@nclab.com. I'm always happy to help out. Let's see, that was Robin. Jessica or Alejandra, did you have anything you wanted to add to that? Alrighty, well, we can continue this offline, so to speak. Oh, there you are. Nothing on my part, just taking in all the great suggestions. Oh, awesome, Robin. Okay, and Alejandra, right on. Sometimes we're the sharers and sometimes we're the sponges. So I'm very glad that you're all here. All right, well, next week we'll tackle the next 2 units in Karel, where I think it's just unit 3, and then I think I have 4 and 5 combined. I'm just going to take a peek at the calendar here and see what's online for next week. Yeah, we're just going to do part 3. And the reason why I thought that was the case, the reason why I just wanted to focus on part 3 is it's really getting into the technicalities of programming. And a lot of times when I get feedback from teachers, that's the one where they get stuck. So, or the students get stuck. So it'll just be on unit 3 next week. All righty. Well, if we're done, we're done. So I wish you all a great week. And yes, every morning we wake up and we figure out what Governor Sisolak has decided and what's going on in the world, and looking for some good news. And so everybody stay safe and have a great week.
Thank you, Sheila.
All right. Bye-bye.
Bye.